Welcome to the lecture on problem solving on decision under risk and uncertainty. So, in this lecture we will solve some problems based on decision under risk and uncertainty. Let us see the first question. The first question is about an agency which has given 4 alternatives to one of its client. The client, after studying alternatives, develops probability distribution describing annual income if invested in particular alternative. The details about the 4 alternatives are like this. You have alternative 1, 2, 3, 4. The probability of giving minus 40, that is 40 lakhs of loss is 0.1, 20 lakhs of loss is 0.2, 20, 40 and 60 lakhs of profit is respectively 0.2, 0.4 and 0.1 if alternative A1 is chosen. Similarly, if the alternative is chosen as 2, 3 and 4, the different probabilities are cited. So, we have to find the expected value of the annual profit and variance value, and based on that we can decide which one should be selected. So, let us see if we get the expected values. So, for alternative A1, alternative 1, it will be minus 40 times 0.1 plus minus 20 times 0.2 plus 20 times 0.2 plus 40 times 0.4 plus 60 times 0.1. So, this will come out to be minus 4 plus 4 plus 16 plus 6. So, it will be 22 minus 4, that is 18 lakhs. Similarly, for 2, if we compute, the expected value will be minus 40 multiplied by 0.05 plus minus 20 multiplied by 0.15 plus 20 multiplied by 0.3 plus 40 multiplied by 0.4 plus 60 multiplied by 0.1. So, you will get here as minus 2, minus 3, plus 6, plus 16, plus 6. So, 28 minus 5, that is 23. Then for third alternative, it will be minus 40 multiplied by 0.4 plus minus 20 multiplied by 0 plus 20 multiplied by 0.1 plus 40 multiplied by 0 plus 60 multiplied by 0.5. So, this comes out to be minus 16 plus 0 plus 2 plus 0 plus 30. So, 32 minus 16, that is 16. Then for the fourth alternative, we have minus 40 into 0.1 plus minus 20 into 0.1 plus 20 into 0.4 plus 40 into 0.4 plus 60 into 0. So, this will be equal to minus 4 minus 2 plus 8 plus 16. So, 24 minus 6, that is 18. So, these are the values of mean or expected values when we take the probability values into account, and using the 4 alternatives we get these expected values. Now, we have to see what is the variance value for them. So, the variance values can be computed. For variance, again for alternative 1, we have to get to these values and we have to have the squares of these numbers multiplied by the respective probability values. So, it will be minus 40 square multiplied by 0.1 plus minus 20 square multiplied by 0.2 plus 20 square multiplied by 0.2 plus 40 square multiplied by 0.4 plus 60 square multiplied by 0.1 minus the expected value square, that is 18 square. So, it will be, if you look at 40 square 1600 square multiplied by 0.1 plus 0.4 plus 400 multiplied by 0.2 plus 0.2 plus 3600 multiplied by 0.1 minus 324. So, this comes out to be 800 plus 160 plus 360 minus 324. So, this is coming out to be 996. We go for the second alternative. For second alternative again we have minus 40 square multiplied by 0.05 plus minus 20 square multiplied by 0.15 plus 20 square multiplied by 0.3 plus 40 square multiplied by 0.4 plus 60 square multiplied by 0.1 minus the value of the expected value is 23. So, it is a square, that is 529. So, you will get 1600 multiplied by 0.05 plus 0.4. So, that is 0.45 plus 400 multiplied by 0.15 plus 0.3, that is 0.45 plus 3600 multiplied by 0.1 minus 529. So, if you compute this value, this comes out to be 720 plus 180 plus 360 minus 529. So, this is coming out to be 731. We will compute the variance for the next two alternatives. Variance for alternative 3, it will be minus 40 square into 0.4 plus minus 20 square multiplied by 0 plus 20 square multiplied by 0.1 plus 40 square multiplied by 0 plus 60 square multiplied by 0.5 minus the expected value is 16. So, 16 square. So, it will be 1600 into 0.4, that is 640, plus 400 multiplied by 0.1, so 40, plus 60 square into 0.5, so that is 1800 minus 256, and this comes out to be 640 plus 40 plus 1800 minus 256. So, it is coming out to be 2224. This is the variance of third one. Now, we will calculate for the fourth one. For fourth one, minus 40 square multiplied by 0.1 plus minus 20 square multiplied by 0.1 plus 20 square multiplied by 0.4 plus 40 square multiplied by 0.4 plus 60 square multiplied by 0 minus this square, that is 324. So, it will be 1600 multiplied by 0.5 plus 400 multiplied by 0.5 minus 324, and this will be equal to 676. So, what we see is that the expected values are coming as 18, 23, 16 and 18. So, what we see, alternative 1, 2, 3 and 4, expected value is coming as, in terms of lakhs, 18, 23, 16 and 18, and the variance is coming out to be 996, 731, 2224 and 676. So, what we see is this is preferred one using the expected value, and the minimum value of the variance is 676. However, this option looks to be better because the variance value is quite reasonably in the case of alternative 2. So, depending upon the choice, you can go for alternative 2. If the expected value is seen, it is maximum here, and also the variance value is closer to the minimum. So, alternative 2 can be preferred. So, this is how we solve the problem based on the expected value or expected variance decision making. Next problem we will discuss about the different criterion in the case of uncertainty, where the profit earned by 3 alternatives under 3 level of sales are given. The probabilities are not given in this case, and you have to use the Laplace principle, Maximin, Maximax rule and Hurwitz rule, and to suggest the best alternative in each cases. So, we will use these different rules to come to a conclusion that which of the alternative is better in this case. So, let us start with the Laplace rule. So, first Laplace rule. Now, in the Laplace rule, what we do is we are giving the equal probability to all the values. So, for alternative 1, if you calculate the profit will be 50 plus 80 plus 80, and equal probability is given. So, you have to divide by 3. So, it will be 70. So, it will be 70 units. Similarly, for alternative 2, you are given the equal weightage. So, that is why it will be 60 plus 70 plus 20 divided by 3. So, it will be 150 by 3, that is 50. You go to alternative 3, and in alternative 3 again you have 90, 30 and 60. So, it will be 90 plus 30 plus 60 divided by 3. So, it will be 180 by 3, that is 60. So, using Laplace rule, you see that alternative 1 should be preferred, which gives you maximum of the profit out of the 3 alternatives. Let us go to the Maximin rule. Using Maximin. Now, in the Maximin, what we do is you are taking the maximum value of the minimum profit being given by each of the alternatives. So, if you look at, it will be maximum of minimum by alternative A1, A2 and A3. So, it will be nothing but maximum of minimum of A1 as well as minimum of A2 and minimum of A3. So, basically minimum of A1 is, as we had done, it will be 50, it will be 20 and it will be 30. So, out of this the maximum value will be 50. So, 50, we have a pessimistic view, we feel that you will get the minimum of the profit for every alternative, and then we try to have the maximum of those minimum values. if you go for maximax, as we know, it is based on the optimistic concept. So, here you are getting the maximum of the maximum values for every alternative. So, that is for 1 is it is 80, for 2 it is 70, and for third it is 90. So, that will be 90. So, based on min, you see that the alternative 1 is coming into picture, whereas using maximax the alternative 3 is under consideration. So, this is how maximin and minimax can be used to come to the selection of alternatives which gives you the desired objective. Now, let us discuss about the third rule, that is Hurwitz rule. Now, this rule talks about a parameter alpha, which is the degree of optimism. So, basically in that case what you do is you get the maximum value multiplied with this level of optimism, that is 0.6, and the minimum will be multiplied with 1 minus alpha. So, basically for alternative 1, alpha is given as 0.6. So, basically maximum of the value is 80. So, it will be 0.6 multiplied by 80 plus 1 minus 0.6 multiplied by the minimum value, that is 50. So, it will be 48 plus 0.4 into 50, that is 20, it will be 68. If you go to alternative 2, now in this case you have maximum of value is 70 and minimum is 20. So, it will be 42 plus 0.4 into 20, that is 8. So, it will be 50. You go to alternative 3. Alternative 3 maximum is 90. So, using this parameter 0.6 into 90 plus 1 minus 0.6 into minimum value is 30. So, it will be 54 plus 0.4 multiplied by 30, so 12, that is 66. So, what you see is alternative A1 gives you the maximum value. So, what we see is using the Laplace rule, you prefer alternative 1, which is giving you the maximum. So, using Laplace, alternative A1 1 gives you the maximum values, maximin alternative 1 again, maximax alternative 3, and the Hurwitz, where alpha is taken as 0.6, the optimism parameter. For that, again alternative 1. So, this is how you come to the conclusion that which of the alternative should be selected, at least in the cases when the probability levels are not mentioned. There is no certainty, which is there is no value of probability being given, and in that cases this is the methods, these are the methods Laplace, Maximin, Minimax and Hurwitz. Hurwitz can be having different values if we change the alpha. If we change the alpha, suppose we change the alpha, we change alpha to 0.2, 0.3 suppose. Now, this will basically change its value. So, in that case it will be 0.3 multiplied by 80 plus 0.7 multiplied by 50. So, in that case it will be 24 plus 35, 59. If you take A2, it will be 0.3 times 70 plus 0.7 times 20. So, it will be 21 plus 14, 35, and if we take here 0.6, so this is 0.3 multiplied by 90 plus 0.7 multiplied by 30, so it will be 27 plus 21, so 48. Again, using even this parameter, we see that the A1 is preferred. So, for this parameter also again we see that A1 is preferred. So, this way you can have different value of the degree of optimism, alpha value, and based on that the alternative can be selected which should be the most preferred ones, and you can use any or either of these methods to suggest the best alternative. Thank you.